Hello everyone. Hello everyone. Good evening. I hope I am audible. Hello everyone. Quickly tell me, am I audible? Good evening everyone. Good evening. If I am audible or not. So yes, I am audible. So great. So first of all, welcome to this amazing 3-day bootcamp of DevTown conducted by DevTown. So in this bootcamp, we are going to build a project that is AI movie recommendation system. I hope you all are excited for this. So we will be beginning the boot camp in today's, or I can say we will be beginning today's session more than like in 2 to 3 more minutes. Okay, so that everyone can join. Till then, uh, let's quickly have a brief introduction. So myself, Lakshya Sachdeva, and I am going to be your mentor for this boot camp, for these 3 days boot camp. So yes, hello, good evening, good evening. I hope my voice is properly and clearly audible, right? I hope my voice is properly and clearly audible, right? Just give me a second, guys. Great, great, great. Yes, the topics that we are going to cover in this bootcamp, I will pick those topics from the scratch, okay? So that will not be a problem. Guys, just give me a second, okay? Yeah. So, okay, any prerequisites? So yes, if you have a basic knowledge of what we say Python and a very basic knowledge of machine learning, then it will be great. If not, then don't worry. We are going to take things from the basic. And to be very honest, we don't require that much knowledge of machine learning as well. Like a very basic knowledge is also okay. Yes, if you are an absolute beginner with a very basic knowledge of Python or we can say ML, then surely you can. This bootcamp is special for you. How to get certificates? So first of all, there are 2 to 3 main criteria for getting the certificates. The first one is that you must fill out the attendance form for all the 3 days. Okay. And the second one, uh, maybe there is a possibility that you guys will get a mini project based on this bootcamp and based on the topics that you are going to learn in this bootcamp. So you guys have to complete that mini project and submit that project in the time given or the deadline. Okay. So this bootcamp is a 3-day bootcamp, and each session will be of approximately 1 hour to 1.5 hour long. Okay. The session will be approximately 10, 8 or 8:30 or something. Okay. Not more than 8:30. Great. So I hope it's time to begin with the session. So let me just share my screen once. I hope my screen is visible, right? Guys, quickly tell me, is my screen visible? Guys, quickly tell me, is my screen visible? Yes, my screen is visible. Great. Great. So let's start with the session. So let me just give you a proper roadmap. So this is a 3-day bootcamp in which we are going to make a project that is AI movie recommendation system. Okay. So this is a 3-day bootcamp in which we are going to make a project that is AI movie recommendation system. Great. And this bootcamp is like for covering two main concepts of machine learning, two very major and important concepts that most of the students leave in between. Okay. So those concepts are, the first one is vectorization. Okay. And the second concept is similarity search. So these are the two major concepts that we are going to cover with the help of this within these 3 days. Okay. So the flow of our bootcamp will be, right now you guys may know or maybe not, you don't know about these two topics, but don't worry, we are going to pick these topics from the scratch and we will do all of the things. Okay, great. So what is the flow of bootcamp? So on day one, that is today, we are going to see a little bit about the data set, like what is the data set that we are going to use and what all things are we going to do. Okay, like we will first explore our data set, explore our data set. The second thing that we are going to do is we are going to perform vectorization. Okay, we are going to see what is vectorization. So yes, we are going to cover one of the two major topics in today's lesson. Okay, we are going to see what is vectorization, and like we can do vectorization in different with the help of different techniques. That is, let's say one technique is one hot encoding. Another technique is, let's say, TF, just a second, TF-IDF. Okay, so this TF-IDF stands for term frequency inverse document frequency, but let's leave it right now. So what we are going to do, we are going to do vectorization with this TF-IDF only. Okay, and there are many more techniques like bag of words and all. So right now we are not going to focus on each and every technique, because obviously this is a 3-day bootcamp only and we cannot cover each and everything. But we are going to cover this TF-IDF part, that how can we use this TF-IDF for this vectorization. Right now many things will be much more complex for you guys, I am pretty sure, because like these are many new words maybe if you are a beginner, but don't worry, you will be going to cover all of these things. Okay, this will be on day one. Okay, and we are going to do pre-process our data. We are going to pre-process our data. So these all topics we are going to cover in day one. Then day two. So in day two, we are going to cover, like we will just first of all we will revise all the previous things. The second thing we are going to do is cosine similarity, similarity search to be precise. We are going to learn about similarity search. Okay, and under the similarity search there are also again many techniques, but we are going to learn about cosine similarity. So this is the topic that we are going to cover in tomorrow's session. Okay, and in day 3 we are going to, and we are also going to build our model in day 2. Okay, so the third step is building our project. So this will be also done in day 2. Then in day 3 we are going to revise, first of all revise all the concepts that we have done in both of the days. Then the second part, we are going to deploy our project. We are going to deploy our project, and there are again many ways to deploy our project, like FastAPI, Flask, and all. But in this bootcamp, we are going to deploy it in FastAPI. Okay, so we are going to deploy our project with the help of FastAPI. Because many of you ask that why I always, not always, but mostly why I deploy in FastAPI and not Flask. Because whenever you are going to deploy your project on Flask, so what's the main problem you face is that you have to create your own front end, and you have to create your own CSS and JavaScript files and all the images and everything. You have to create your own, like, okay, like whole interface. But in FastAPI, you just have to create an API that can be easily connected to any front end or back end. Okay, in FastAPI, you just have to create one API that can be connected to any project. Okay, but in Flask, you have to create your own interface and everything to connect. So that is the advantage of FastAPI. So we are going to like cover all of these topics in 1 hour most probably. Okay, so like in day 1, so all the topics in day 1 we are going to cover it in 1 hour. Great. So this is a basic roadmap of all the 3 days. So we are going to, let's cover the day 1 first of all. We are going to explore our data set. We will see what is actually vectorization and what is pre-processing. Okay, like how can we pre-process our data. So first of all, let's start with day 1. So this is our day 1. So let's begin. So my question is, how many of you know what is machine learning? How many of you know what is machine learning actually? Quickly, you can answer in the chat. Okay, I'm seeing the chat all the time. Okay, so quickly answer in the chat. How many of you know what is actual machine learning? And give me the definition as well. Okay, give me the definition of machine learning if you know. A very basic definition will also work. Okay, so give me a definition. What is actually machine learning? Okay, so many of you know. Teaching machine by feeding data, great. Prediction of the output, great. Machine learning, basically guiding AI, okay. A machine is said to have learned if its performance P improve over time T with experience E, okay. So if I just give you a very basic definition, many of you have given the correct definition, of course, but if I have to give a very basic definition, so I will just say I have some kind of data. Okay, I have some kind of data. I am feeding this data to a machine. Here machine is my system, my laptop, my computer, anything. Okay, so I have some kind of data. I am feeding this data to my machine, and my machine is learning from this data. My machine is learning from this data, so that whenever I am going to ask a question, whenever I'm going to ask a question to the machine My machine can give me output based on this data. Okay, so let me explain it again. I am giving some data to my machine. Okay, I am giving some data to my machine, and this machine of mine is learning from that data. This machine of mine is learning from this data in such a way that whenever I will ask some question to my machine, it will give me some kind of output. Okay, it will give me some kind of output based on what my machine has learned from this data. I hope this definition is very much easier to understand. Just focus on my words. I am giving some data to my machine. My machine is learning from this data in such a way that whenever I'm asking some question from my machine is giving me the output based on what my machine has learned from the data. Now tell me, is this basic? I know your definition is also correct, but a very basic definition if I have to give, like if any of you don't know about machine learning is, so this is a very basic definition. Okay, when your machine is learning, from the name itself you can tell machine learning. From the name itself you can say when the machine is learning. I hope this definition is pretty much clear to everyone. Quickly tell me guys, if everything till now is clear, write clear in the chat. Okay, quickly guys, quickly. Machine can be anything, like my system, my laptop. My laptop is a machine right now. If you have a computer, your computer is a machine. If you are working on a phone, your phone is a machine. So anything can be your machine. Yes, the machine learns with some kind of algorithm, some kind of mechanism. Great. So till now everything is clear. Yes. Let's move on the next step. So as you know, when machine is learning, so machine learns from some kind of algorithm, right? So machine learns with the help of some kind of algorithm. The machine learns with the help of some kind of algorithm. So those algorithms are known as models. Okay, you must have heard about, like there are many models: linear regression, logistic regression, and XGBoost, random forest, clustering algorithms. There are many models and algorithms you must have heard about. Okay, so I'm not going to discuss about all of the models right now. If you want to check out about these models and everything, you can see the previous bootcamps of mine. I have explained all the models and everything in those bootcamps. Okay, so in this bootcamp we are not going to discuss all of those models, but okay, so when we are going to feed some data to this model, okay, let's say I'm going to take a model AB. Okay, so this is my model. So let's say I'm going to take a model AB. So now what's the first step? The first step is feed some data, feed some data to my machine or to my model, right? I'm going to feed some data to my machine or to my model AB. Now, sir, when we are going to feed some data, when we are going to feed some data, okay, sir, what should be the data? Sir, in which form should we feed our data? Sir, in which form should we feed our data? So if I say your data can be in numeric form, your data must be in numeric form. Okay, I am saying my model AB. Okay, I am saying my model AB accepts the data. My model AB accepts the data in numeric form. Is this clear? Till now everything is clear, guys. Quickly tell me. Till now everything is clear. Yes. Okay. So I am saying I am going to feed some data to my model AB. I am going to feed some data to my model AB. So my data, I am going to accept this data in numeric form. Okay. I am going to take this data in numeric form. Now my question is, let's say my data consists of, let's say, my data consists of uh, hello. Okay. So I have this word in my data. So, sir, this is a string. Sir, this is a string. But my model only accepts the data in numeric form. Now, sir, how can I give this hello? That is, how can I give this string? How can I give this string to my model? Sir, how can I give this string to my model over here? Because AB only accepts the data in numeric form. So what I can do, I will simply convert this data into numeric form. I will convert this data into numeric form and then I will feed this to my AB model. I will change my data into numeric form and then I will feed it to my model AB. So when I am going to change this data into numeric form, we call it vectors. So this is a very important term, guys. When we are changing our string data or some data, character data or some string data into numeric form, we call it vectors. Okay. So actually what vectors are? These are the distances actually. Like if I just go in the mathematical portion, so vectors are the distances from the graph portion and everything. So right now I am not going to go into those mathematical portions because it will take a lot of time to explain. But let's say if I am going to feed this data to my model AB, I am going to convert this data into vectors. Okay. Right now I'm not going into the mathematical part of vectors. If I just have to give you a basic explanation. So let's say this is a graph of mine. Okay. And I have a point, let's say a point over here in this graph. So what my vector is, let's say the distance, if we say the distance from origin or the distance from one point to another, we call it some kind of vectors. Okay. So I'm not going to go in the mathematical portion of vectors right now, but in simple terms, if you have some string data or some character data and you have to feed that data in your model, so how are you going to feed that data? You're going to convert the data. You're going to convert the data into vectors. Okay. You are going to convert the data into vectors. you can feed those vectors into your model. I hope a very basic meaning of vectors is clear to you guys. Vector means actually, how can I explain you in short terms? Uh, so vector is kind of a distance in graphical format when we are going, like in graphical format, if we are going to measure the distance, we measure it with the help of vectors and everything. Okay, like what is the distance of this to this and everything. Yes, many of you are giving the definition with both magnitude and direction. Vector is a quality. Yes, all of these can be a definition of vectors, but for machine learning purpose, uh, not this basic definition works. We are like there is a very deep meaning of vectors, very deep mathematical intuition of vectors as well. So that is not possible to cover in 1 or 2 days. Okay, so that is why I am not going to take this vectors topic in detail, but yeah, we can cover this vectors topic in any other bootcamp, of course. But right now, we are not going to take this vectors topic in detail. Okay, just try to understand when we are going to train our data, train our model on some string or character data. So we are going to convert this data into vectors. Okay, we are going to convert this data into vectors, and then we can feed those vectors into our model. And this conversion over here, this conversion over here, conversion from string to vectors, okay, or lines or paragraphs to vectors, we call it vectorization. Okay, we call it vectorization. I hope this much is clear, guys. If everything till now is clear, please write clear in the chat. Not the data is not converted into zeros and ones, but we are going to see. Okay, just wait for a minute. When we are going for the practical implementation, I will show you how vectors look like. Till then, if everything till now is clear, please write clear in the chat. Vectorization is the process of converting string into vectors. Yes, we can say. Okay, great. So if some of the topics or some of the concepts is not clear till now, so don't worry. I will explain it once again when we are going to do the practical portion for vectorization especially. Okay. So let's continue with the practical portion now. So I will quickly open Google Colab. Okay. So in Google Colab, you guys can also do the coding. New notebook. Okay. You know what I will do? I will change the profile quickly. Just a second, guys. Yes. So as you can see, I have opened a Google Colab notebook over here, and you guys can also open this Google Colab. Yes, we can say with the help of vectorization, it is a kind of pre-processing step. Okay, vectorization is kind of a pre-processing step before we feed our data into the model. So if we have any categorical data or any, let's say string data or something, so we must pre-process that data before feeding it to our model. Okay, so I've quickly opened my Google Colab over here, and let's say I'm going to give it name AI AI movie. Okay, so this is the name I'm going to give my Python file, ipynb file. Google Colab. Okay, Google Colab. You can see collab.research.google.com. Okay, or you can simply write Google Colab. Okay, you can simply write Google Colab, and you can open up the first link that comes. Okay, I have simply opened my Google Colab over here. Okay, so let's quickly start. Now the first thing is I am going to import my data. Okay, I am going to take the data. So I have a data set downloaded, and I will share the data set with you guys as well. Okay, I have a data set downloaded over here. First, I will open the file from the left hand side. Okay, if you can see this file option, I have opened the file option over here, and you can also check if the collab is working or not. You can simply write print hello world. Okay, so as you can see, it printed hello world. So this means that our collab is properly connected, or if not connected, so you must see an option to connect from over here. Okay, so we can clearly see that our Google Colab is connected. Now what I am going to do, I am going to upload a file, upload my data set over here. Okay, I am going to upload my data set over here. So from here I will simply write yes, so here's the data set that we are going to use, and this data set will be shared to you guys. Worry. So as you can see, yes. Okay, just a second, it is loading. Could not fetch from backend. Okay, so it's still loading actually. Yes. So I hope it will show us the data set now. Yes. So as you can see, this is the data set over here. That is the index, budget. Okay, I will show you the data set not over here. Just give me a second. Okay. So the next step is, so we have this data set over here, right? So the first step is now we are going to import some libraries. We are going to import some important libraries. Okay. The libraries are, first of all, I am going to import numpy as np. Okay. So if you guys have a basic understanding of Python, you guys must have heard about the libraries like numpy and pandas. Okay. So I am going to import these two libraries, that is numpy and pandas. So if you guys ask me what is numpy and pandas, so like I will just explain you in brief. Numpy is a library which is used to, let's say play with the data sets. Okay, how can I explain? Let's say if I have a data, like I have to create a matrix, or I have to like adjust some values of the matrix or data sets and everything. So that is why we use numpy. And pandas is used to create data frames. Okay, I will just show you with the help of example. Okay, let me import other libraries such as import difflib. So what is this difflib? I'm going to explain it in tomorrow's session. Okay, we are not going to use this difflib in today's session. The next thing I'm going to import is from sklearn dot feature extraction dot text. I'm going to import TF. Okay, it's giving some error. IDF. Okay, sorry, it's not import. Okay, I've made a mistake over here. It's from sklearn dot feature extraction dot text. I'm going to import TF-IDF vectorizer. Okay, So I'm going to explain what is this TF-IDF vectorizer. Okay, so wait for just 2 to 3 more minutes, 5 to 10 minutes, and I'm going to explain what is TF-IDF vectorizer. And then we have to import from sklearn dot metrics dot pairwise. I'm going to import cosine similarity. And this cosine similarity is, again, we are going to discuss this in tomorrow's session. In today's session, we are majorly focusing on TF-IDF vectorizer. So I will run this cell quickly, and as you can see, this cell has run successfully. Now the next line is, I am going to take this data set of mine. I am going to take this data set of mine. How can I do that? I will simply write movies underscore data is equal to pd dot read underscore csv. Now, sir, what is this pd? So pd is nothing but pandas. Sir, why are we using pandas? So pandas give us a special function, that is read csv, through which we can read any csv files. Okay. So over here, I just have to give the path of this csv file. And what is the path? So I can just simply copy path over here. I can simply click on these 3 dots and I can copy the path, and I will paste the path over here. Now if I will run this cell, you can see it runs successfully. Now if I will write movies dot movies underscore data dot head, you can see the data set over here. Now, sir, what is this dot head? So if I will print the data without this dot head, you can see there are, like, the row number is 4802, 4801, 4800. So like there are 4800, approximately 4800 rows, right? So with the help of dot head, I am just printing the top 5 rows. Okay, 0, 1, 2, 3, 4. So with the help of dot head, I am printing the top 5 rows only. But if I'm not going to use dot head, so it will print all the rows. I hope this much is clear. I will provide the dataset, so don't worry, you will get the dataset after this session. And yes, this collab notebook will also be shared to you guys. All the code, all the notes that we are making, and the dataset and everything will be shared to you after the session ends. Yes, you can do it in the Jupyter notebook as well. I hope everything is clear. If you have any doubts, then you can ask in the chat right now. I am seeing the chat. If everything till now is clear, guys, please write clear in the chat and we will move forward. Quickly, guys. No, the data set is not clean. We are going to see. The data set, I have taken this data set from Kaggle. Okay. So if you guys want, you can also pick the data sets from Kaggle. It is a very good website. Else, I will share this data set to you guys as well. Okay. So don't worry. Yes, the collab link will also be shared. So let's move on. So let's quickly look this data set. Okay, so we have this index. So sir, we don't need this index. Okay, sir. Sir, why use cosine? So there are many more metrics through which you can find the similarity or something. But we, in this project, we are going to use cosine. Okay, we are going to understand why cosine in tomorrow's session. Okay, so don't worry right now. So the next thing is budget. So I don't think so for the movie recommendation system we would require this column. Okay, so as you can see, there are approximately, okay, sorry, if I'll just print it this way. So as you can see, there are 24 columns, right? There are 24 columns in our data set, but we don't need all of these columns. We can find the data set in Kaggle. Okay, we can find it in Kaggle. So as you can see, we have 24 columns. We have 24 columns, so we don't need all of these columns. So we are going to take only selected columns from this whole data set. Okay, we are going to take the column like genre, okay, genre, or like home page. I don't think so it's required. Then we can take the overview column, and there are like 24 columns. Okay, so whatever column you see like that is a proper or required column, you can take that column. Okay, so we are not going to take all the columns. Okay, sir. Now what's the next step? So as you can see, with the help of this, uh, just by simply writing movies underscore data, you can see your data set, complete data set over here. So now what I'm going to do, and also if you want to like see how big is your data, you can simply write movies underscore data dot shape. Okay, so this will give you the shape of your data set. Like your data set is consists of 4803 rows and 24 columns. Okay, so this will give you the shape of your data set, like how many rows and how many columns. Now the features that I'm going to select from these data set, or I can say the columns that I'm going to select from these data sets are, let's say I'm going to take selected underscore features. I'm going to make a list of all the selected features. Let's say I'm going to take genre, then I'm taking the keywords. Okay, then let's say I'm taking the tagline, then let's say I'm taking the, after tagline I can take the cast, and after that let's say I'm taking the director. So these are the selected features that, or we can say these are the columns that we are going to select from our data set. Okay, so I have taken all of these features. Now I will simply create a for loop, that is for feature in selected underscore features. For feature in selected features, I'm going to take movies underscore data of feature is equal to, sorry, it's movies underscore data dot of feature is equal to movies underscore data of feature dot fill in a. Okay, so now let me quickly explain you guys what I have done over here. So as you can see, I have this big data set, right? I have this big data set, right? I know many of the things are not clear right now. Let me explain. All of, like, I have a data set, I have a very big data set over here. The data set consists of 24, if I am not wrong, yes, 24 columns. The data set consists of 24 columns, right? So what I'm going to do, I'm not training my model over 24 column data set because this is a very, very big data set. So what I'm going to do, I am going to clean my data. Okay, I am going to clean my data. So how can I clean my data? I am going to simply remove the unnecessary columns. I am going to simply remove the unnecessary columns. Sir, how can we remove the unnecessary columns? Oh, okay, I have two options, right? I can either remove the unnecessary columns or I can take all the necessary columns. Okay, either I can remove all the unnecessary columns or I can take all the necessary columns. Okay, sir. So after seeing this data set, some of the necessary columns that I thought are genre. Okay, sir. Then the, let's say, uh, where I've taken that. Yes, tagline. Then we have the cast. Then we have the director and all. Okay. So for me, these are the important columns. Okay. Genre, keyword, tagline, cast, director. For me, these are the important columns. Okay. So what I have done, I have created a data set. I have created a data set with all of these important columns only. So instead of taking all the 24 columns, I have created a data set with only, now if I will print movies underscore data over here, you can see this time, okay, sorry, it is still showing 24 columns. Okay, what's the error over here? Index, budget, home page. I think I have missed something. Movies underscore data pd dot read csv movies. Okay, sorry, actually I have to combine these. Okay. Sorry, actually I what I have taken what I have done over here. So in this movies underscore data, okay, in this movies underscore data, in this movies underscore data, what is feature? What is feature? Let me just explain you via the keyboard. Okay, yes. So let's say this is my data set. Okay, this is my data set. Okay, this is my data set first of all. Now let's say I have some values like 1, 2, then there is a blank space. Okay, then 3, 4. So this is my data set. Okay, let's say this is my data set. Now if you guys can see, there is a blank space over here. If you guys can see, there is a blank space over here. But sir, is a blank space a good technique for our data set? Sir, is a blank space good technique for our data set? No. So how can I fill this blank space over here? Sir, how can I fill this blank space over here? So there is a function named as dot fill na. Okay, there is a function known as dot fill na. So with the help of this function, dot fill na, I have filled the blank space over here. With the help of this function dot fill na, I have filled the blank space over here. The blank space over here that I have got in my data set is now filled with an empty string. Let me show you. Is now filled with an empty string. Okay. So this is how I have filled the blank space in my data set. I hope this is clear. So I have used this dot fill na to fill up the empty space in my data set. And now I am going to combine the features. Now I am going to combine the features. Okay. So what I will do, I will create a variable named combined features. I am going to create a feature that is combined features. Okay. In that I am going to take movies underscore data. What all features I am going to take? I am going to take genre. Okay. Then I am going to take, let's say I am simply writing plus. Okay. I am taking an empty space over here. Then I am taking plus. You will see shortly what I am doing over here. Okay. Then I am going to take movies underscore data. Then again movies underscore data. I am going to take the feature keywords. Then again a plus. Then again a space plus. Now I am going to take movies data tagline. So what I'm going to do, I'm simply copying this. I'll paste it over here. So instead of this keywords, now I have to take tagline. Okay. Then I have to take cast. And then I have to take director. Okay. Then I have to take director. And I will simply run this. So what I have done over here, I have taken all the features that I have chosen over here. Okay. Like I have chosen 5 features over here, right? So I have taken all the features, that is the genre, keyword, tagline, cast, and movies data. I have taken all of these features and I have combined all of these features over here. Okay. I have combined all of these features over here. Now the next step is, if I will print this combined features, if I will print these combined features, you can see all of the features are now combined over here. If I will print this combined features, okay, so you can see all of the features over here are now combined. I hope this much is clear, guys. I hope this much is clear, guys. If everything till now is clear, write clear in the chat. Else if you have any kind of doubt, you can ask me in the chat. Why to combine? Okay. So when we are going to apply vectorization, right? So we can also apply vectorization on different columns. But to prevent applying vectorization to all the columns and everything, we have combined all the important features together, and now we can apply the vectorization on this one feature only. Okay. So this is the technique I am going to follow. If you want, you can take all the features differently and you can apply vectorization on each and every feature. That also works. This combined feature is just a feature column. Okay, this is not any kind of data set or something. Like we have just combined all the features. Okay, this is a feature column. We can add this feature column in our data set as well, but right now I have not added it. Okay. Yes, the recorded session will be there on YouTube every time. Okay. Now, sir, how to perform vectorization? Sir, how to perform vectorization over here? So to perform vectorization, we can simply write, first we have to initialize our TF-IDF vectorizer. Okay. So I am simply writing vectorizer equal to TF-IDF vectorizer. Okay. So I have initialized my TF-IDF vectorizer. I will run this cell. In the next line, I will write feature underscore vectors is equal to vectorizer dot fit underscore transform, and I am going to apply it on combined features. Now, sir, what does this mean? Sir, what does this line mean? So what I have done, first of all, I have initialized my TF-IDF vectorizer. Okay, sir. Then with the help of this dot fit underscore transform function, I have applied this vectorizer on my combined features. Okay. So if I am taking different features in different columns, so I have to perform this particular step multiple times. Okay. So I have to perform this particular step multiple times so that I can convert all of these features in separate columns into separate vectors and everything. But when I have combined all of these columns, so I just have to simply vectorize it for once only, and all the features will be vectorized. Now if I will write feature underscore vectors, okay, sorry, I have to write print feature underscore vectors. So as you can see, these are some values. Okay, these are the vectors that we have converted. I hope this much is clear. So what we can see, this whole line, this complete line, this string or this paragraph, this sentence is now converted to a vector, or to, we can say, is converted to a numerical value. I hope this much is clear. I hope this much is clear, guys. If everything till now is clear, write clear in the chat. If you have any kind of doubt, you can ask in the chat. So this is how we can convert our string or sentences or paragraphs into vectors. Now after vectorization, we can apply the further cosine similarity, or we can feed this into any kind of model or anything. So what is going to happen after vectorization, we are going to see in tomorrow's session. Yes, the dataset will be provided in the community with all the notes, all the dataset, and all the like coding files and collab notebook, and everything will be provided to you guys in the community only. String number 15. Okay, yes. So what I am going to do, what I have done over here, I have first initialized my vectorizer, right? My vectorizer is helping me to convert the strings into vectors, right? So I've initialized my TF-IDF vectorizer into this particular word vectorizer. Then I've applied this vectorizer over my combined features. What is my combined features? These features are my combined features. Okay. So I've applied my vectorizer over this combined features with the help of a function that is dot fit underscore transform. What if we select the features from dataset and apply the vector? Yes, it will also work. It will not be a problem. So this is how we can apply the vectorizer on our dataset. So I don't know if it's time. Okay. So if I just give you a very basic theory, let's say I'm not interested in taking you in the deep maths of this vectorization part. But if I give you a very basic theory, so TF stands for term frequency, and IDF stands for inverse document frequency. TF stands for term frequency, and uh, IDF stands for inverse document frequency. So there are some formulas so that which help us to calculate this TF-IDF. So to calculate TF, the formula is number of repetitions of words in sentences divided by number of words in sentences. Okay, so this is the formula to calculate the TF, that is the term frequency. And to calculate IDF, the formula is log of base 2 number of sentences divided by number of sentences containing the word. So these are the two main formulas for TF-IDF, that is term frequency and inverse document frequency. Then we simply add up these TF plus IDF and we get our vectorizer. So I'm not going to take you in the whole mathematical concepts because obviously we don't have time for that much concepts and everything. But yes, so this is a very basic explanation of what is actually happening behind TF-IDF. I hope this much is clear, guys. So this is a very basic thing, like what is happening behind TF-IDF, like how what are the main formulas and how we got our vectorizer and everything. Like there is a much more deeper concept behind TF-IDF also, but right now I'm not going to explain that. Like we if in short, if I am going to explain, we take some matrix and we calculate the TF for each and every word, and we create a particular matrix for that. Then we create a different matrix for IDF, and we combine both of those matrix, and based on that resultant matrix we can get the TF-IDF vectorizer and everything. Okay, so I'm not going to go in that much detail. So this is the basic working behind the TF-IDF. What is the difference between word embedding and vectorization? So again, this is all. So if I have to explain in a very basic terms, word embeddings is like I have a word stored in my dataset, and if I have another word that I have to find, so I find the similarity between those two words, and I will get the embeddings between those two words. So I'm not going to go in detail that much. So this is a very basic difference. I hope you guys got to know how can we use TF-IDF. We can surely do one more thing, that instead of combining these features, we can take different features on different columns, but then we have to like apply the vectorizer on each and every column and everything. So for ease of work, we can say we have combined all of these and we have applied the vectorizer on the single column. All of these formulas are applied within this TF-IDF vectorizer. With this one line, we have applied all of those formulas. I hope everything is clear, guys. So in day one, what we have did, we have taken the dataset and we have learned what is actually TF-IDF, what is actually vectorization. Like we have converted these our dataset into vectors now. I hope this much is clear. Yes, in short, in today's session, what we did, we took the useful columns and we vectorized all those useful columns, and we have the numerical values now. We have the vectors now. And now what we are going to do in day 2 of this bootcamp, we are going to work on these vectors only. Yes, we can separate them and find the do the vectorization again. So this is it for today, guys. I hope you guys must have learned something from this session, and the attendance link is there in the chat. So please guys fill out the attendance form, as it is very important for the certificate criteria. So please fill out the attendance form for today's session. And in day 2 of this bootcamp, we are going to see what is cosine similarity and what is the use of cosine similarity and everything. Okay, like what actually is similarity search. Thanks a lot guys for joining today's session. I hope things are now clear to a little bit of things are clear to you now. All the code, all the notes, the data set will be provided to you guys. Yes, we can give any name to the function. The data set is well balanced, so I don't think so the data set is balanced, because I just took a raw data set from Kaggle. So if you want to do more pre-processing, you can balance the data set. I have just filled the null values, right? So you can do many more things on the data set. You can take some different columns, some more useful columns. You can do anything. Okay, I will provide the data set and you can do anything to the data set. Yes, there are web development bootcamps that are happening. So you can go to DevTown channel, YouTube channel, and check out the bootcamps, the upcoming bootcamps and the previous bootcamps as well. Yes, this video is available on YouTube, so you can watch anytime. Okay. Yes, in the pre-processing step, you can also remove duplicate rows and everything. So we are going to complete this project within 3 days. Okay. So 1 day is completed. Now there are 2 days, 2 more days remaining. So in those 2 days, we are going to complete the session, complete this project as well. Okay. So this is it for today, guys. Please quickly fill out the attendance form. And thanks a lot for joining today as well. So let's meet tomorrow at the same time, that is 7 o'clock in the evening, and we will continue with the similarity search push. Okay. I don't know anything about Python. Can I perform good in project? If the things and if the concepts are clear to you, then surely you can perform good in this project. Thanks a lot, guys, for joining. If you have filled the attendance form, you can leave, and let's meet tomorrow, 7 o'clock in the evening. Thanks a lot for joining, guys. Thanks a lot. Okay. Thank you, guys.